In the first few lessons of this chapter, we learned to solve systems of linear equations. And those systems of linear equations we could graph, we could use substitution, and we could use elimination, or also called addition for. And we're going to be able to use those same strategies to solve these quadratic systems. Obviously, or hopefully you remember that when graphing, the solution to our systems is where the two graphs intersect each other. And you can have different types of systems. We had consistent, independent, and that is a system now up until now that had one solution, but really a consistent, independent system is a system that has a finite number of solutions, so a countable number, and we'll see a little bit later what type of consistent, independent solutions we can get. In these cases, we can get up to 4 solutions, and I'll show that later. We can get consistent dependent, which means the two graphs were actually line one right on top of the other, and there was an infinite number of solutions. And then we have an inconsistent system where the systems didn't intersect at all, which means there's no solution. So we've dealt with parabola already, and we know how to graph parabolas. And actually we know how to graph parabolas that go in this direction. We also can have parabolas that go that open right or open left, and that is when the just the y squared is y term is squared. What we're going to do is I'm just going to show samples of each of these because we're not going to necessarily do graphing because of the inaccuracy it can cause or have. But I'll show you these graphs so you can visually see what will happen. Obviously, we know what a circle is, so you could have a circle on your graph. You could have a parabola, and yes, we could have the ones that open up or open down, but as I mentioned before, they can open left or right. An ellipse is really an elongated circle. So an ellipse looks something like this, and now it could look this way, or it could be a vertically facing ellipse, something like this. And then lastly, we have a hyperbola, and a hyperbola can open up and down. There's this part right here is the hyperbola. It has 2 parts to it. So when we solve a system of equations, we can have different types of solutions, and obviously we have the inconsistent where they don't intersect, an ellipse, and a parabola. Well, this ellipse and parabola don't intersect at all, so this would be no solutions. So I'll put the number of solutions up here. We could have, let's say, a circle and a hyperbola. Maybe the circle and hyperbola end up looking like this, where there's just one solution. So you could just have one solution. You could have maybe a circle with a parabola, and you can see you have 2 solutions. Maybe you have an ellipse with a parabola, and you can see you could have 3 solutions, 1, 2, and 3, and maybe a hyperbola. So that's our hyperbola along with a parabola. You could get 4 solutions. So out of our consistent independent type of solutions, that's these right here, you could have 1, 2, 3, or 4 solutions, and obviously you can have 0 solutions, so that would be inconsistent. So these right here would be consistent, independent. And although we could graph them, it can be inaccurate and cumbersome. So we're going to use substitution and elimination, and we'll show a few examples of how to do each of these. So in our first one here, this is actually set up pretty nicely for substitution because y is equal to x squared plus 1. If you use substitution, you need to have one variable on one side. So the y's on this side and any x values on the other. Now this just has an x squared, but if there was an x squared and a 3x, they would both have to be on this side. And if there was more than one y, like a y squared and a y, you would have to have them on the left. So this is set up nicely for substitution. So what we'll do here is we'll take this and we'll put that in for y right here. We're going to substitute it in there. So we have x minus y. So y we know is x squared plus 1 is equal to negative 3. And now we have a quadratic equation that we've learned how to solve. So we will distribute this negative. So we have x minus x squared minus 1 equals 3, negative 3. And then it helps to get everything on one side. We don't usually prefer to have a negative x squared. So let's get everything to the right side. So we have a positive x squared. So we'll add x squared, subtract x, and add 1. And we'll do what we do to one side, we have to do the other side. And when we do that, we get 0 here on the left side equals, and we'll put these in descending order, x squared minus x, and then negative 3, and 1 is negative 2. And now we want to solve a quadratic. Well, we have a few tools to solve quadratics. We can factor, complete the square, or use the quadratic formula. Normally factoring is the easiest, and if that's not possible, we go to the quadratic formula. And so let's say, I think we can factor these. So we have an x and an x. To get our x squared, we have a negative 2, which means we need a plus and a minus. And we want factors of 2 that will give us a negative 1x. So we need a negative 2 and a positive 1. And now, just a quick review, if two things multiply together to equal 0, one of them's got to be either equal to 0. So either x plus 1 equals 0, or x minus 2 equals 0, which means x equals negative 1, or x equals 2. And so we found our x values. Now we have two x values, so we have to plug both of those x values back into one of our originals. So what we'll do is let's plug in negative 1. And so I'm going to put it into this one. Well, you know what? The first one's easier because it's already in y equals form. So the first one we have y equals x squared plus 1, and I'm going to plug in the negative 1. So when we plugged in negative 1 squared is 1, plus 1 is 2. And so one of our solutions is x is negative 1 and y is 2. But we also have this solution of x that we need to plug in, so let's plug that in. Y equals 2 squared plus 1. Again, I'm putting it into this first equation. And 2 squared is 4 plus 1 is 5. And so we have the solution 2. We put 2 in for x, and we got 5 for y. And we have two solutions here. And these solutions, what happened, these will make both of these true. So if we put in negative 1, 2, they'll make them both true. If we put 2 and 5 in, they'll make them both true. If we think about the graph, this isn't going to be an accurate graph, but this is a parabola, and this is a line. And those intersect at two places, and that's why we have two solutions there. So we use substitution to work our way through getting those two answers. So this would still be considered consistent independent. So consistent independent, we'll abbreviate there. All right, this one here, we really could use substitution or elimination on, and maybe I'll end up using both and showing you both ways to do this. But elimination, we actually have a y squared and a y squared both here. Sorry about that. So we have a y squared and a y squared here, and to combine these, we usually want one to be negative. And now Also thinking of our elimination, if we eliminate these y squareds, we will just be left with x variables. There will be an x squared and an x term, but they'll just be x variables. So just to let you know, this is going to be a circle intersecting with a parabola, so we could have 1, 2, 3, or 4 solutions, or no solutions. So let's see what happens here. So what I'm going to do here, I'm going to keep this one the same, and then I'm going to multiply the bottom one by -1. And I'm just going to say we're going to multiply by -1 here to give us a negative x minus y squared, and that's why I multiplied by the -1, so these would be opposites, equals -7. And now we're going to do our addition, which eliminates the y squared. So x squared minus x, be careful, these aren't like terms, so we have to leave this as x squared minus x. Y squared minus y, that becomes 0, equals 2. And we're going to subtract 2 from both sides. X squared minus x minus 2 equals 0. I think this is the same quadratic we had on the last one, so we're going to factor this. And this is an x and an x. We want a positive and a negative. And we get x plus 1. Oops. X plus 1. And an x minus 2. Which, solving these, we get either x equals -1 or x equals 2. And now what we need to do here is we need to plug these back into one of our answers, one of our equations up here. Let's plug them into the second one. We want to solve for y. So we have x. Let's not do that. We have x, which is, we're going to put in -1 plus y squared equals 7. So I put that into the bottom equation. And so solving here, we're going to add 1 to both sides. We get y squared. Adding 1 to both sides gives us 8. And take the square root. Remember, when we take the square root, we have to do plus or minus the square root of 8. And for right now, we can leave it like this. We'll learn a little later how to simplify these radicals. This is actually equal to 2 root 2. But again, we'll get to that later. So we when we put -1 in, we got two separate answers. We got x is -1 and y was positive root 8. And then we also got negative square root of 8. And then after we put the -1 in, we can also put this 2 in. So we'll put 2 in for x. Again, we're putting it into the bottom equation. So 2 plus y squared equals 7. We're putting into this equation right here. And we'll subtract 2 from both sides. We get y squared equals 5. Take the square root of both sides. And when we take the square root of both sides, we have to put plus or minus. So we have y equals plus or minus root 5. Which means when we put 2 in, we either got positive root 5, or when we put 2 in, we got negative root 5. And so in this case, you see that there are 4 solutions. -1 root 8, -1 negative root 8, 2 root 5, and 2 negative root 5. So we have 4 answers there. These are our solutions. We could write this in a simpler way. You have to be careful with this not to overgeneralize, but when we put -1 in, we got plus or minus root 8. This really shows us 2 answers here because -1 positive root 8 and -1 negative root 8. And then our other solution could be written 2 plus or minus root 5. And you can use that to write your solution. Our last one here, we have, this ends up being a hyperbola. This is a circle, so again we could have 0, 1, 2, 3, or 4 solutions. This one, we could use substitution or elimination. I think I'm going to go with substitution because what we can do here, now in the past we've solved for just x, but here we have an x squared and here we have an x squared, so maybe we could solve for this x squared and plug whatever we get in for x squared. So I'm going to take this, I'm going to subtract y squared from both sides, which gives x squared equals 4 minus y squared. And again, normally I might think, oh, I need to take the square root of both sides, but this is what I want, an x squared. So I can plug this in for x squared. And so let's write that 3 times x squared. Well, here x squared we just learned is 4 minus y squared. We're substituting in minus 5y squared equals 4. And now notice we have an equation here with just y squared, so we can solve this. We'll distribute. We get 12 minus 3y squared minus 5y squared equals 4. And we get like terms. We have 8y squared, so 12 minus 8y squared equals 4. And notice here, this is already just a perfect square. So let's just go ahead and solve for y squared. We don't need to complete the square or factor. We can subtract 12 from both sides. And I'm saying that because we don't have the linear term. We don't just have a y to the first in here. Negative 8y squared equals negative 8. And divide by negative 8, we get y squared equals 1. So dividing both sides by negative 8. And then we take the square root of both sides. And square root of 1 is just 1, because you think of what multiplied by itself as 1. So we have plus or minus 1. So again, we have two solutions here for y, 1 and negative 1. So we're going to plug both of those in. It seems like this equation, so when doing substitution, usually the easiest one to plug it into is the one that you solved for. So we have x squared equals 4 minus 1 squared. And then that's plugging in the positive part. And then we're going to do x squared equals 4 minus negative 1 squared. And so x squared, 1 squared is 1, 4 minus 1 is 3. Take the square root of both sides, remembering to put plus or minus. Over here, remember we square first, so negative 1 squared is 1, 4 minus 1 is 3. So get the same equation here. And so x is plus or minus root 3. And so we can write our answer when we had 1. I'm going to write it as 4 solutions. We got root 3, or we got 1 negative root 3. From these two, we put in negative 1, and you get root 3. Or negative 1 gave negative root 3. It could be combined into 2, like from this one, we had 1 plus or minus root 3, and negative 1 plus or minus root 3. And so this is an answer. This is an answer. Now, in fact, we can, with this one, this is kind of a rare case. You can't often do this, but we had 1 went with plus or minus root 3, and negative 1 went with the same thing. So we could actually also put plus or minus 1 goes with plus or minus 3. This tells us 4 solutions right here. 1 with positive root 3, 1 with negative root 3, negative 1 with positive root 3, and negative 1 with negative root 3. Be very cautious in writing it this way. People have made mistakes when they come across this and they try to combine too much, but any one of these 3 answers is correct, and any of them can be used to show our solution. So that's solving systems of quadratic equations.